Hello everyone. Now in that sessions we have to study about hydrogen fuel cell, supercapacitor and BMS, that is battery management system. Now what is a fuel cell? A fuel cell is an electrochemical cell that converts a chemical energy from fuel into electricity through an electrochemical reaction of hydrogen fuel with oxygen. A fuel cell are continuous source of fuel and oxygen, usually from air, to sustain a chemical reaction like a IC engine. Without using a waste heat, its efficiency is 40 to 50%, and with the heat recovery, it is 80%. Byproducts are H2O in the form of vapor. Now, construction of hydrogen fuel cell. Now here the construction diagram of hydrogen fuel cell are shown here. Now here a hydrogen from fuel are shown in that figure. Then here a positive and negative supply are shown in that figure. Then electrolyte are placed here. Then anode and cathode are shown in that figure. Then here a heat plus water, that is H2O, are shown in that figure. Then oxygen, that is air, are shown here. Now the basic construction of hydrogen fuel cell consists of two electrodes, an electrolyte, a fuel, that is hydrogen, and power supply. An electrolyte that separates two electrodes is an ion conductive material which facilitates the free passage of ions as shown in that figure. In a fuel cell, an oxidizing agent or oxygen is made to flow through the fuel, that is hydrogen, and hydrogen and oxygen combine to form a water and generate a heat as shown in that figure. At the anode, hydrogen is stripped of its electron and its proton is made to pass through an electrolyte. The electron made to pass through a DC, external DC, that is direct current circuit to power device as shown in that figure. Here a DC supply, that is positive negative supply, are shown in that figure. Now advantages and disadvantages of hydrogen fuel cell. The advantages of using hydrogen fuel cell are listed below, that are hydrogen is abundant resource, then fuel cell do not emit a harmful emission, then hydrogen gas is non-toxic and does not produce any harmful byproducts, then high efficiency and powerful energy production, then hydrogen fuel cell are highly fuel efficient, and hydrogen fuel cell is a renewable source of energy. So that are the advantages. However, there are some disadvantages of hydrogen fuel cell that are mentioned below, that are expensive to construct and maintain. The storage of hydrogen gas is difficult. Then compressed hydrogen gas is highly flammable. So that are the advantages and disadvantages of hydrogen fuel cell. Then application of hydrogen fuel cell. Some of the application of hydrogen fuel cell are listed below. It is used for fuel rockets and can even provide a water supply through pure H2O emission. Then what is a supercapacitor? A supercapacitor SC is a high capacity capacitor with capacitance values much higher than other capacitor but lower voltage limits. They have high power density and deliver a high amount of energy within a second. They can be best suitable for electric vehicles during accelerating and currently used during a regenerative braking. Then what are the main parts of supercapacitor? That are electrode, electrolyte, separator, current collector, terminals. Then what is the voltage rating of supercapacitor? It is 2.7 volt per cell. Then what is the capacitance value of supercapacitor? It is in faradic only. Then can supercapacitor replace a battery? In and toys and buses are tried in Hong Kong for short distance of 5 km with a huge capacity of ultra capacitor. Then What is the effect of supercapacitor is used with a battery or fuel cell in EVs. So life of battery, then FC will increase, a maintenance will reduce, and low capacity battery or fuel cell will be required. Then difference between supercapacitor batteries and fuel cell with the characteristics. So first one is charge or discharge time for a supercapacitor or chemical capacitor. It is in millisecond or second. Then for batteries it is 1 to 12 hours, and for fuel cell it is 1 to 300 hours. Then operating temperature per centigrade for supercapacitor -40 to +85 degrees centigrade, for batteries -20 to +65 degrees centigrade, and for fuel cell it is +25 to +1000 degrees centigrade. Then operating cell potential, that is delta Phi by Phi, for supercapacitor it is 2.3 to 2.75, for batteries 1.25 to 4.2, and for fuel cell 0.6 to 1. Then capacitance in farad, for supercapacitor it is 0.1 to 2, and for batteries and fuel cell it does not exist. Then lifetime for supercapacitor it is 30,000 plus hours, for batteries 150 to 1500 cycles, and for fuel cell 1500 to 10,000 hours. Then weight per kilogram for supercapacitor 0.001 to 2, for batteries 0.001 to 10, and for fuel cell 0.002 to 10. Then power density per kilowatt kilogram inverse, for supercapacitor it is 10 to 100, for batteries 0.005 to 0.4, and for fuel cell it is 0.001 to 0.1. Then energy density per watt hour kilogram inverse, for supercapacitor it is 1 to 5, for batteries 5 to 600, and for fuel cell it is 300 to 3000. Then what is a battery management system? A battery management system, that is BMS, is any electronic system that manages a rechargeable battery pack, such by protecting a battery from operating outside of safe operating area, then monitoring its state and calculating secondary data, reporting that data, controlling its environment, authenticating it, and balancing it. So that is battery management system. This controls a circuit, improves a performance of battery, and increases a life and reduces a risk of accident regarding battery. So that is a battery management system. Now the construction diagram of battery management system are shown in that figure. So here a data acquisition systems are used. So here a battery monitoring data regarding a current, voltage, temperature uh, are shown here. Then it is given to a data acquisition system, and here a safety protection are provided to it. Then here a thermal management system are shown here, and electronic control system are also shown here, and here a communication block are also shown here for the communication data between a data acquisition to a state determination, then a user interface, then electronic control or thermal management are shown in that figure. So that is BMS, that is battery management system. The need of battery management system. So it is a heart of all type of energy storage technology. Then ensure optimum uses of energy inside the battery, powering the three portable or stationary system. Then risk of damage inflicted upon a battery minimized. Then enhance system runtime reliability and increases overall system efficiency. So that is a necessity or need of battery management system.